All right, Dave, looks like we've got a group here. So if you would like to kick this off,
Okay.
we'll hand it over to you.
Very good. Hey, everybody. I've had quite a time this last couple of weeks here. I've been back doing a bunch of radio planning and some other fun stuff, which at some point in time we're going to talk about here in one of our Tech Talk sessions. We'll break it down into little pieces and go over some of the finer points of RF planning. But in the meantime here, I've had a couple of questions over the last few months about how to test and what we should do. And I decided that today I would take and talk about that and settle on some of the finer points of a program we all love or would like to love called IPerf. But anyways, let's get going here. Let's oops, let me got to get my right window clicked on. Very good. All right. So one of the primary issues that you have when you go to put up a wireless network is that you got to test the thing. You got to know that it's doing what you want it to do, and so when we're installing pieces, we're installing a base station. We can we can test the base station. We can do parts and pieces and whatnot. But at some point in time, we have to go from the subscriber, our subscriber or endpoint, whatever our customer is on the network, back through to our core. We got to verify that we have the performance that we say that we're going to have, and it tests our RF planning, it tests our data design, it tests all sorts of things, and we need to be able to do this. And I've found over the years that the simpler that you make this test, the actual more information that you can get out of it. And sometimes when it comes to good IP design, whether it be wireless or cabled or by fiber, sometimes the simplest testing gives us the best results. So here we have we're going to talk about it from mostly the end-to-end perspective today, but I will of course talk about some access point to subscriber unit testing and that we can do in this hour as we're going through this information. I love this little graphic here on the right. Sometimes it's the way that we feel like taking to a network. Sometimes when it doesn't work right, you see the two guys with the chainsaws. That's they're fun kind of guys. So, all right, we need to know that our network is performing properly. These days, IP networks are on demand. We have no idea when the subscriber is going to click the mouse, is going to take and say, I need bandwidth on this service. There's no idea when this is going to happen. When we're building the network and we're doing acceptance on the network, testing from a single AP to a single subscriber module, very easy. Right, we got essentially a point-to-point. So all we're doing is we're going to take and have some sort of laptop or some other device at the subscriber module that's going to test to some device that's on the data side of the access point, and we're going to run it, and boom, we'll see how good our RF link is. We'll see some characteristics of the RF environment. When we go to a single AP to multiple APs, it starts to get, or multiple SMs, I should say, it starts to get a little bit more complex because now we have to have some kind of probe, some kind of testing device at all of the subscriber modules. Plus, we have to have a device at the access point that will handle the data from our multiple subscribers. So this becomes a little bit more complex. Even more complex than this, we have to do multiple AP to multiple SM testing at some point in time. So lots of times that is actually live network is the only way that we have enough gear that we can actually see what's going on. And we need to trust the numbers that we see in our network management system, in other systems that we use providing QoS, for just generally running the network. We need to be able to take and analyze those numbers. So in the beginning of all of this, we need to be able to have a good idea of how the network is operating. All right. So primary testing. Not every test needs to be completed every time. Testing is almost always done in stages. The first stage is acceptance. When any equipment is first installed, we test all of its functions. We test individual performance between components within that we have access to. These days, with for instance, in LTE, with the EPC being embedded in the base station, we can no longer test between the EPC and the base station, but we can test from the layer 3 PDN, of course, through to the subscriber module. So we need to be able to break the network down as much as we can in order to take and test the individual bits and pieces of the network. Most access points allow that are layer 2 type or layer 3 type of access points these days, such as Cambium's 450, for example. We can take and test from the access point itself through to the subscriber unit. There's built-in RF testing, so we can test the quality of the link, and then we can take and throw a laptop or some other kind of probe on it, the subscriber module, and test back through to the access point before we have it live. That's the whole idea of acceptance testing. And then, of course, we need to document everything while we're doing this so that we can take and form up a baseline as to how the equipment is performing. So make sure that the network management system that you're using will keep track of the KPIs that you need. One of the challenges that some operators have is that when they turn up the equipment, the NMS is not sophisticated enough to be able to handle the KPIs that you need to be able to make intelligent decisions on the network performance. So you need to make sure that as part of your planning, make sure that you have the NMS ready to go before you have the network on the air. Even it's make sure the NMS is up, and maybe through lab testing, make sure that it's keeping track of the values that you want, that it's doing the things that the NMS is supposed to do. Then periodically, as you grow your network, you should select random CPE devices to test through your network. Some operators will take and have a probe subscriber module that's maybe mounted at the tower or whatever the case, that can take and connect to any one of the access points that are at the tower, or base stations that are at the tower, and that's a permanent test facility. These are important to make sure that that your network doesn't degrade slowly, because sometimes with well, say antennas being subjected to the weather, to water ingression and other things, that the network might degrade at a rate that you don't actually see it happening. If you test now and you test 6 months from now, you'll see the difference. But if you're looking at it, at the numbers every single day, you may not see that the peak last night was 68 megabits on a particular sector, and the peak next week is 62 or 61 megabits, and you're not quite sure why the demand has gone down. But it's not that serious at that moment, but it will become serious over time. So we need to take and make sure that we maintain the baseline. So we do that by placing probes, what I call probes, in strategic parts of the network. We can test, and I am a big fan of short-term IPerf tests that will take and measure the performance between two devices. So probes can be as simple as I'm showing here. There's a little stack of Raspberry Pis. They can be as inexpensive as that, just as long as you've got a device that can handle the volume of traffic that you need between your devices. Maybe you need a little bit more horsepower than that in the core, something that will, measure gigs or multiple gigs as we're coming in the future. But generally for stuff up to a few hundred megabits, some, a little device like that for 30, 40, 50 bucks is more than enough when you have them strategically placed. Anyways, so I think I dropped off when I was explaining how does it work. So client talks to the server, and sets up a path on a particular IP port, and then the runs data from the client to the server. Then if you've set it to turn around, there's an option to turn around. It'll take and send data then back from the server to the client. And so you can do both. You can do them both at the same time. You can do simultaneous uplink and downlink, or you can take and do it one then the other, or you can take and after a test, you can specify that the client becomes a server and the server becomes a client, and then you do the same test all over again. It depends on the capability of the devices that you have that are running IPerf. IPerf can be used for either connection data, TCP data that has that uses a particular port and is connection specific, or it can be run with UDP data, which is connectionless, and just throw the client will just throw a bunch of data at the server, and then the server will tell you what the transmission parameters of that burst has been, and same back and forth. And it comes in some different flavors. People have the IPerf itself is a command line interface program. You open up in Windows, you'd open up a command box or PowerShell and run it from there. Or in Linux, you open up a terminal, or you can take and there are a number of different GUI versions. JPerf, for example, that has a GUI front end, and so then you can take and see the options and that, just looking for JPerf. All right, so I got a couple of examples here of client mode and server mode. The red box here you see is a Raspberry Pi, and it's so of course it's running Linux, and we can see that I've set it up as IPerf-S, simple server, and it's listening on port 5001, which is the standard port for that. And on the green box over to the side here, we have another Raspberry Pi that's running IPerf as a client, pointed at the IP address of the server, and then with a number of options in behind it, which we're going to talk about as we go along here. And you can see that it too connected on port 5001, but it will take and move off to another port. You see 39996 is during the actual testing. So it tests on or sets up the connection on port 5001 and then moves off to another IP port to complete the testing. If you have a firewall in the way, you have to take and set up IPerf so that it uses a particular port all the time so that you can get through the firewall. And if you're testing across a NAT, an IP version 4 NAT, you will get the client to the server to work, so you'll see the uplink, but the server will not be able to establish a path through the NAT back down to the client if your NAT is set up as a masquerade like most are, and no DMZ or any other hole cut through it that allows this to work. So IPerf works best in an environment where you're behind your firewall, you're behind your NATs. If you got any, or you're testing inside of your network rather than from the inside to the outside. All right. I'm sure everybody's heard about Raspberry Pi. I am deeply enamored with this little computer. Depending on the type that you get and the options that you get with it, ranges anywhere from 39 bucks up to 100 bucks or a little bit more these days. And it's a It's an ARM processor, so it's a lightweight processor. You can buy them with up to 2 gigs of RAM. It has built-in Wi-Fi, Gig E, USB, of course, and inside it's got an I/O connector that you can do other things with, and it may be powered by AC, by DC, or by power over Ethernet with the right adapter board on the inside. And one of the things that I like about it is that Ethernet 0 and wireless LAN 0 can operate at the same time. So like any Linux box, you can have it so that you can have connectivity to the device through the Wi-Fi and be testing over the Ethernet, and or vice versa, whatever your network setup is, what you're trying to do with it. So it's very, very flexible, and it can run a Linux desktop so that you can remotely access it through VNC. So if you wanted to see to log into the desktop, a GUI desktop of Raspberry Pi, you simply can, and it works just fine. Very handy device. So when we talk about probe placement now, these you know, an Ethernet probe works the best when you have it in a place where it can parallel the traffic that's meant to flow across that link. So for example, I've got 2 sites here. I got in this particular case, in this graphic, and I've got a switch stack on either side of them. It could be a switch or router stack, doesn't make any difference what the device is. And I've got my pair of, in this case, Raspberry Pis are plugged into each of those. And so then that lets me test in the direction of the arrows away from the tower if I want to on the network, or I can test in between the towers when I just simply set up one as a client, one as a server. We're going to see that in my demo coming up here in a few minutes. Now, IPerf has a lot of options. So when you run it, if you run IPerf with --help, you'll get a list of the options. They come in 3 sections. The options do. So there's options that are related to the client-server relationship. So for example, whether or not you're going to do TCP, which is the default, or use UDP, you add a -u, and what the window size, the TCP window size might be, or the socket buffer size that you're going to test with. You need to make it big enough so that it loads your network properly. You can take and bind ports and devices so that IPerf uses that particular interface to do its testing. And one of the features that I like, and I've used it maybe a few times, and it's been very handy, is to be able to set the type of service byte field, and so then I can take and raise the QoS level to get to test you know, a high QoS path. In the case that I've used this in the past for is when I set up a dedicated bearer on LTE. I have the default bearer, which would have an IP toss of 0 or best effort, and then maybe I've set up a SIP connection in a dedicated bearer, and it's got a toss of 26 or 46, and so I can take and run IPerf over 46, and I can take and make sure that I am actually injecting my data properly. I'm filtering my data properly and putting it into the dedicated bearer. So very, very handy. From a server perspective, when you set up an instance of it as a server, -s runs it in server mode. That would be the primary option that you would use. And we saw in the little setup before that, that's all you need to take and make the server go is run an IPerf space -s, and away you go, or -- server, the word. I can take and set a time limit that I want to listen for new connections. So if you just set up IPerf and let it run, it will sit there and it'll listen until you reset the device or kill the service. But we can take and set a time limit for that. And again, we can bind either multicast addresses or a device into the server instance so that the server is using a particular port in a case where there's multiple options available to it. And the dash capital D there, run it as a daemon, means that I can take and run it as a service inside of my Linux instance, and it frees up the terminal for something else. If I run it as a server, then the terminal is dedicated then to that service. And if I close the terminal, I will take and kill my my IPerf server service. If I want to run it as a daemon, then I can take and just set it up, run it, and leave it. And we're going to see in the future here that as more and more devices become IP version 6 enabled, that IPerf already is capable of running an IP version 6, which is really kind of nice. From the client perspective now, I've got a number of options that I can do. Again, I've highlighted the ones in yellow are the ones that we would take and I use the most often. So if we could run down the list, we can see, of course, that we have to start the instance in client mode, and then we have to specify a host that we're going to connect to. That host can be IP version 4 or 6. Then I can select whether I'm going to do a simultaneous test, a -D, or I'm going to do a trade-off, a -R, meaning that I'll test the upstream first and then downstream. Dual test, of course, does it both at the same time. I can take and specify the number of seconds that I want to take and run the test. Default, if I don't specify a time, is 10 seconds. Kind of a nice short round interval for testing. Let's any switches that need to populate forward databases and stuff, get that done, and then you can run your time, run for that length of time. Or you can take and set it up for many thousands of seconds. I've taken and run tests, IPerf tests for 2 days, and it will take and it will run just fine. So it's an awesome tool to use during acceptance of your base stations, because you could take and set up a probe that's running an instance of IPerf, and then take and set the test to run for a number of days, and it will exercise. Run as much data through the equipment as what the equipment will support. So it's great from that perspective. I can run parallel streams. So if I wanted to run more than one stream, if I needed more than one IP stream, a TCP stream, for example, to be able to load down a pipe, I could take and specify the number of streams that I want to run. And then, of course, I can reverse the client server. So I can make the server the client and the client the server just by simply doing a -R, and the way it goes. Very good. All right. So my lab here today is going to consist of actually 3 different terminals and 1 server. So I'm using Raspberry Pis for my 3 endpoints, but I have a case here where I have an IP version 2 client that's built into the Telrad CPE that I've got in my Telrad LTE lab, and of course I've been anything from Gemtech or from KZ Manufacturing or other CPE manufacturers build IPerf into their operating system, and so you can do it from just about any. But I have my Telrad lab that's running here in this particular case. So I have. Let me take and bring this down. All right. So this will be I'm gonna just let me lift this up out of the way, and we're going to take and this is, oh, come on back. Annotate. There we go. It's going to be the server. This is going to be my server. So I'm going to take and log into the Pi right here. Done 80. It should be right. It's going to ask me for a password here eventually. Should everything be working right? Oh, maybe I have to. After a little network dump, I think I have to take and I'm actually connecting across my network here, so I'm going to turn on my internal VPN. Let me, whoops. Let's discard that. Okay, so all right, so there we are. We're logged into the Wi-Fi. I have logged into the Raspberry Pi, I should say. My Wi-Fi is turned off, and so I'm ready to go here. So I'm going to run IPerf as a server, and I'm going to have it give me an indication of what it's doing every 5 seconds. So that should be good enough. Oh, bind failed, already in use. That's fine. Let's clear the screen. Oh, let's exit from this. There we go. Let's exit from that. And boop. There's the window that's actually running. Beautiful. Now when the internet dropped, that kind of really hosed everything up here for me. So isn't that nice? So let's log back into here again. All right. Now let's take and we're going to go. Oops. First of all, let me go back here. Let me go from the current slide. There we go. Back to here. All right, so we have our server set up and running. So now let's take and we'll connect first to this client that I have that's connected to my 450s. So minimize that window. Or let's go to 75. Right there. All right. Okay, so now I'll do IPerf-C. So as my client, I'm going to connect it to 172.29.128.80. And I'm going to set my window size to 256K. I'm going to watch every 5 seconds. I want a feedback from what it's doing here. I'm going to set my time to 20 seconds, and I'll get my segment size that it settles out at the on the test. All right, so this is going to go for 20 seconds from the client to the server. So we can see that how much the volume of data that I've transferred in this 5 seconds, in this case, 50 some megabytes, and I am attaining 90 megabits per second. My maximum segment size in this case is 1448 bytes. The MTU is set to 1500 over the link, and so that's all working as I would expect. Now I'll do it one more time, and let's do a trade-off. So we can take then and of course see 20 seconds in the again in the uplink first, and there's 10, comes 15, comes 20, And now we switch around. We do where I have it randomly selecting a downlink port. So in this case, 32.896 is the IP port that it selected. And then we can see the throughput between my server and my client. And I happen to have my QoS on my 450 multi-point network here set up very close to this. So I can verify the performance here. This is a simple test. This is going from one client to one server, and so essentially we can see how steady it is. We can see many things about it. I can take and if I were to bind or do any of those things, I could specify at this point in time. But let's leave that. Let's put this aside. Whoops. And let me whoops. Let me go here. Let's just discard my annotation just for now. And let me open up another PowerShell. Drag it back down here. Okay. So let's take a look at from a slightly different perspective. We're going to take a look at the Raspberry Pi that is on the other side of Telred LTE CPE, and I have a very poor RF path at present. So in order to take and demonstrate what it does, that might see on a poor link in the field. So 10.121.1.1 should be it. And there I am again, password, and there I'm in. And so if I run IPerf to the same client, 172.29.128.70, I should say. And I'm going to, again, do a 256K window. I'm going to look, I want an indication every 5 seconds, I5. I'm going to do it in both directions. And I'm going to set the time for I'll just do 10 seconds. So we'll just do it by default here. So there you go. So there it is. It's set up the port has connected. And so there's first 5 seconds, 1.5 megabytes for my uplink. So there's 10 seconds have gone by. And then I connect it the other way. And of course, as I mentioned, I said the RF conditions are really, really poor. And so there we see the performance that I achieved over that link end to end. Now, one more thing here. If I where did I go here with that must have closed also. Okay, well, this will be fine. Yep. Just took a while to come up. Don't want to click it twice, and I did. Nice. Just the mad clicker here. All right, so let's 72.20.255.1 oops 241 will be port 8080. All right, so here we have one of my LTE CPEs, 12,000 operator, and Telrad 4G are the default passwords, username and password. And so as I go along here, I can go into my monitoring menu. There's my IPerf menu. And oops, come on. There we go. And I already have run an instance to that 172.29.128.80 server. So I'm going to use port 5001, the default port. I'm going to measure for 30 seconds. I'm going to use TCP, and we're just use a single stream. And away I go here. So IPerf's running. Now in this case, the way that this is set up, there is no feedback for it, so I don't see my results every 5 seconds, or the options are set here inside the CPE in the firmware. But at the end of the 30 seconds, I will see what the results were for the uplink, and then I will see after that what the results are for the downlink from the server to the client. So let's just, there we go. Okay, let me drag this down. Okay, so there we have it. So again, it's about the same amount of data as we had before. So I see I've got 1.4 megabits in the uplink, and over that 30 seconds, 1.4 megabits per second, and the downlink will be finished here shortly, and it will give me a number. I'm quite certain. There we go. And so we got 23 megs in the downlink to the CPE. So now I've tested this without, in this particular case, without involving the customer, because of course the customer would be the Raspberry Pi that we just looked at. So I can take and with the same device in the center of my lab here, I can run throughput tests and run this for as long as I need to gather the statistics that I need to, it's a pretty simple tool to use. If you haven't been using it, I recommend getting used to using it, because it's a very nice way an easy way to take and gather up statistics, print them out as text, and keep records of what's going on in your network. All right. Let me dismiss all this. Okay, so there we have it. We're back at the Raspberry Pi, then on the other side of the 12,000, and let's go back to here from the current slide. I want to take and set it up. There we are. All right. So just a simple little demo today, and I don't know, sometimes the simplest things jar us in the right way to take and maybe if you had a problem in the past, and I know sometimes I'll see a little demonstration on or I'll read a little article, and boom, I'll get the method of how I'm going to solve my problem from this. So I hope that this kind of has been that way with you. It's a simple little test. It's a simple little process. But if I were doing troubleshooting on a network, and you showed me what the throughput test was on the first day that it was installed, and then if we're troubleshooting or doing an audit or whatever, you show me what the throughput is today, and we can see the difference between the two, just with a little capture of the output of an IPerf session between a probe in a known location and probe in known locations. It gives a lot of data as to what's going on, and if you're using the equipment's built-in maximum information rate or committed information rate algorithms, or if you're using an external one such as Preseam or some other to manage your levels, 5, 6, and 7, OSI levels 5, 6, and 7, then this is a very, very simple tool to take and keep track of what your network is doing. So anyway, we took 45 minutes here, and I don't want to take too much of your time, but that was just a simple little demo of IPerf. Next month, as we do a new one here, I'm going to do a short little primer on IP version 6. And so in my lab here, of course, IP version 6 is running, and we'll go over some of the steps to enable it in some ways that are kind of interesting. Anyways, thanks very much for your attention today, and have a good day. And we'll talk to you again soon. We'll see you.